Okay, so today we are doing perimeter and area in the coordinate plane. So it's just basic stuff that you already know. We're just going to apply it to the grid. All right, so essential question is how can you find the perimeter and the area of a polygon in a coordinate plane? So what we're going to learn is to find the perimeter and areas of all polygons in the coordinate plane. So let's get started. It says, remember, perimeter has the linear units such as feet or meters. So let's go and do, it says, given the vertices, find the perimeter for each of the following polygons. So the first thing we need to do is plot the points. So let's go with a red. So -2, 3. So what we need to do here is, it looks like, let me make these axis a little darker. So let's go with, this looks like it's going this way and this way. We may have to do this on all of them because they seem to be pretty light. Okay, so now, so -2, 1, 2, 3. So there's point A. And then let's see. So now let's go 3, -3. 1, 2, 3, 1, 2, 3. And -2, -3. So now I'm going to connect them. So there. And I will fix AC because it is a little crooked. All right, there we go. All right, so now, if we're going to find the perimeter, remember that perimeter of a triangle is side 1 plus side 2 plus side 3. All right, so let's go with 1, 2, 3, 4, 5, 6. So this side is 6. 1, 2, 3, 4, 5. This side is 5. So side 1 is 6 plus side 2 is 5. Now remember, to find side 3, we can just do the Pythagorean theorem and get that. So if I did a squared plus b squared equals c squared, then that would be 6 squared plus 5 squared. 36 plus 25 would be 61. And of course, I would need to take the square root to get c, and in the calculator it would be about 7.8. So this side is 7.8. So now I just add them all together and I get that the perimeter is 18.8 units. So the perimeter of triangle ABC is 18.8 units. All right, so now let's do it again with 4 points. So -1, 1. I hope it fits. And I have a feeling I may have, let's start these over. So I'm going to just move these axes over where they're more in the middle. All right. So now, -1, 1. So there is point A. 4, 1. 1, 2, 3, 4, 1. So there's point B. 2, -2. So there, oh, I'm labeling these wrong. This is K, L, M, and 1, 2, 3, 1, 2. And there's N. All right, so now I'm going to use my little line tool to connect them so that they're nice and straight, because we all know how horrible I am with this. All right, so now I can go through here, and now I'm going to find the perimeter. So I know anytime it's horizontal, 1, 2, 3, 4, 5, I can just simply count. 1, 2, 3, 4, 5. So this one's also 5. But anytime it's slanted, I'm going to need to do the Pythagorean theorem. So if I were to draw these two here, I would get that this is 2 and this is 3. So that would be 2 squared plus 3 squared. And then, of course, I would need to take the square root. So 4 plus 9 is 13. And the square root of 13 is 3.6. So this is 3.6. So this side here is 3.6. So I'm going to do the same thing with this side over here. I'm going to draw my little right triangle. This is 3 and this is 2. So it's the same triangle. So this would be 3.6 also. So the perimeter of quadrilateral is 3.6 plus 5 plus 3.6 plus 5, giving me a total of 17.2 units. All right, now let's talk about finding the area. Remember, area has square units such as feet or meters, so this would be feet squared or meters squared. In our case, we're going to be using units, so it's going to be units squared. So it says find the area of polygon number 1. Well, polygon number 1 was a triangle, so the area of a triangle is base times height divided by 2. Now, the cool thing is this is a right triangle. So since it's a right triangle, all you need are the legs. Okay, all I need are the legs. So the area of a right triangle basically is like saying leg times leg divided by 2. So that's how you find the area of a right triangle. So the legs are 5 and 6. So that would be 30 divided by 2, which is 15 units squared. Okay, and it says to find the area of the polygon in number 2. So that was a parallelogram. So it's just base times height. So let's go back and look. Wrong direction. Okay, so the base is 5. Now the height is the perpendicular distance, like this. So that would be straight up and down like this way. So that would be 1, 2, 3. So our height is actually 3. So the height is 3. Well, that didn't work out so good. So now let's go back here. So we know that I don't want that. I just want a regular pen. Thanks. Okay, so the base was 5. The height was 3, giving me 15 units squared for that parallelogram also. Easy enough. All right, so now let's look at the next one where we have composite figures. This has a composite because there's more than one picture here. So let's find the perimeter of triangle ABD. So ABD. So they're wanting this top triangle. 1, 2, 3, 4, 5. Okay, that's 5. That's easy. 1, 2, 3, 4, 5, 6. That one's 6. So if I did 5 squared plus 6 squared again, so 5 squared plus 6 squared, and then I'm going to need to take the square root. So 25 plus 36, take the square root, is 61. Take the square root. You get 7.8. Okay, and then here on the perimeter would be 6 plus 5 plus 7.8. So that would give me the perimeter as being 18.8 units. So there's my answer. Now let's find the perimeter of triangle BCD. So that's this one down here. Well, I know this piece is 6. These two are slanted, so I'm going to have to do my little trick. So if I do my little right triangle, 1, 2, 3, 1, 2, 3, 4. So 3 squared plus 4 squared, take the square root, 9 plus 16, is 25, and the square root of 25 is 5. So this is 5. And then I'm going to do the same thing with this one. So 1, 2, 3, 1, 2, 3, 4. Well, it's the same. This one's also 5. So the perimeter of this one is 5 plus 5 plus 6, giving me 16 units. Okay, so now let's look. It says find the perimeter of quadrilateral ABCD. So what they actually want now is the perimeter of this triangle. So A, B to C to D. So they want this whole thing. They want the whole thing. So that is going to be 5, 5, 5, and 7.8. So all the sides are 5 plus 5 plus 5 plus 7.8. So that's 5, 10, 15, so 22.8 units. Okay, and then the next one. Now they want me to find the area of triangle ABD. So remember, the area of a triangle is base times height over 2. So if I go back here and I look at triangle ABD, so I'm going to go back here and delete these dark lines. Okay, so now, let's see. So since this is perpendicular to this, we know it's a right triangle. So if you'll remember, I told you all I had to do is multiply the legs. So that's going to be 5 times 6 divided by 2. 30 divided by 2 is 15 units squared. So ABD is 15 units squared. And I'm not real sure what just happened there. Let's write that out again. 5 times 6 divided by 2 is 30 divided by 2, which is 15 units squared. All right. So we're writing with a normal pen. All right. I don't know what keeps happening. 15 units squared. So 5 times 6 divided by 2, 30 over 2, 15. All right. Now it says find the area of triangle BCD. So let's look at triangle BCD. BCD. So now they want the area of this one. Well, since these two right here are opposites of each other, I know that this is a 90-degree angle here. So I'm just going to, actually, let's do this. Let's go base times height. Let's go base times height. So I know the base is 6. So area is base is 6 times the height. So now let's look at the height. The height is 1, 2, 3, 4. Okay, so the height is 4. So that would be 24 over 2, which is 12 units squared. So the area of the whole thing, well, that's going to be the area of quadrilateral ABCD. So area of ABCD equals area of ABC plus the area of BCD. So that would be 15 plus 12, which is 27 units squared. So just by breaking it into two pieces that I am well aware of learning, I was able to just add them together and get my answer. See you next time.